Have you ever stood before something so magnificent, so impossibly precise, that it made you question everything you thought you knew about the past? For over 4,500 years, the Great Pyramid of Giza has done exactly that. Rising from the desert sands like a mathematical riddle carved in stone, this ancient wonder has guarded its secrets with the patience of eternity itself. But what if I told you that everything we thought we knew about this monument was just the beginning? What if the pyramid we see today, massive as it is hiding something even more extraordinary beneath its weathered limestone blocks? What if modern science has finally found a way to peer inside this ancient giant without breaking a single stone? Tonight, we're diving deep into one of archaeology's most electrifying discoveries. A hidden chamber that has remained sealed for millennia, detected not by pickaxes or dynamite, but by cosmic rays from the depths of space. We're talking about revolutionary technology that reads stone like an X-ray reads bone, revealing voids and passages that the ancient builders never intended us to find. This isn't just another pyramid theory. This is hard science meeting ancient mystery, and the results are rewriting everything we thought we understood about human capability 4,000 years ago. By the end of this journey, you'll understand why particle physicists from around the world have abandoned their laboratories to chase ghosts in the Egyptian desert, and why this single discovery might be the key to unlocking the greatest engineering puzzle in human history. So settle in, because we're about to explore not just what lies hidden within the Great Pyramid, but how a technology born from studying the universe itself has finally given us the power to see through stone, through time, and through the carefully guarded secrets of the ancient world. Deep beneath the unforgiving Egyptian sun, where the Great Pyramid casts its eternal shadow across the Giza Plateau, something extraordinary has been happening. For nearly a decade, teams of international scientists have been conducting what might be the most ambitious archaeological investigation ever attempted. They're not digging, they're not drilling. Instead, they're using invisible particles from outer space to peer inside one of humanity's most enduring mysteries. The project is called Scan Pyramids, and it represents a complete revolution in how we explore the past. Imagine trying to understand the layout of a massive, windowless building while standing outside, knowing that breaking down the walls isn't an option. That's exactly the challenge archaeologists have faced with the Great Pyramid for centuries. Until now, our understanding of its internal structure came from the passages and chambers that ancient builders left accessible, or from invasive explorations that risked damaging the monument itself. But what if there was another way? What if we could use the very cosmos as our spotlight, illuminating hidden spaces with particles that have traveled millions of miles through the void of space, only to reveal secrets buried in stone? This is where the story gets truly fascinating. Every second of every day, our planet is bombarded by cosmic rays, high-energy particles racing through space at nearly the speed of light. These particles originate from some of the most violent events in the universe: exploding stars, colliding galaxies, and phenomena so extreme that they accelerate matter to incredible velocities. When these cosmic rays slam into Earth's atmosphere, they create cascades of secondary particles, including something called muons. Now, here's where it gets interesting. Muons are like the universe's natural X-rays, but with a crucial difference. While X-rays can penetrate skin and tissue but are stopped by dense bone, muons can punch through hundreds of feet of solid rock. They're constantly raining down on us, passing through our bodies, through buildings, through mountains, as if these solid objects barely exist. But here's the key. While muons can penetrate almost anything, dense materials like stone do absorb some of them. The denser the material, the more muons get absorbed. For the teams working at Giza, this cosmic bombardment represents the perfect tool. By placing sensitive detectors around and inside the Great Pyramid, they can count muons coming from different directions. Areas where fewer muons are detected indicate dense stone. Areas where more muons pass through suggest empty space, hidden chambers, or voids that have remained sealed since the pyramid's construction over 4 millennia ago. The genius of this approach is that it's completely non-invasive. The pyramid itself becomes a giant detector, with cosmic rays serving as the illumination source. No drilling, no damage, no risk to one of humanity's most precious monuments. Just patient observation as the universe itself reveals what lies hidden within. But the Scan Pyramids project didn't start with a single team or a single technology. This is international science at its finest, with researchers from Japan, France, Canada, and Egypt working together, each bringing their own expertise and equipment. Japanese teams deployed nuclear emulsion films, technology originally developed to study particle interactions in high-energy physics experiments. French researchers contributed gaseous detectors and sophisticated computer modeling. Egyptian archaeologists provided essential knowledge of the pyramid's known structure and historical context. The beauty of this collaborative approach is that it provides multiple independent confirmations of any discoveries. When 3 different teams, using 3 different technologies, all detect the same anomaly from 3 different positions, you know you've found something real. And that's exactly what happened in 2016, when the teams detected their first major discovery, a corridor-shaped void located behind what's known as the chevron area on the pyramid's north face. This wasn't a tiny cavity or a construction gap. The initial measurements suggested a structure at least 5 meters long, positioned directly above the pyramid's main entrance. But detecting something is just the beginning. The real challenge was understanding what they'd found. Was this an intentional chamber, built for some specific purpose by the ancient architects? Was it a structural feature, designed to distribute the enormous weight of the stone blocks above? Or was it something else entirely, a space that held significance we couldn't yet comprehend? The answer required years of additional research, more sophisticated equipment, and measurements so precise that they could map not just the existence of the void, but its exact dimensions and shape. What emerged from this painstaking work was the confirmation of something remarkable: a hidden corridor approximately 9 meters long, with a cross-section of about 2 meters by 2 meters, featuring a distinctive chevron-shaped roof that mirrors the architectural style of the entrance below. This discovery alone would have been groundbreaking, but it was just the beginning. As the teams refined their techniques and expanded their coverage of the pyramid, they detected something even more extraordinary, what they now call the Big Void, a massive, empty space located above the Grand Gallery, one of the pyramid's most impressive known features. The Big Void represents something unprecedented in pyramid archaeology. We're talking about a space at least 30 meters long, potentially larger than any known chamber within the Great Pyramid. Its position, directly above the Grand Gallery, suggests it might be related to that structure's function, but its purpose remains one of archaeology's greatest mysteries. The implications of these discoveries extend far beyond simple curiosity about hidden rooms. They suggest that the Great Pyramid's internal architecture is far more complex than we ever imagined. For decades, archaeologists and engineers have marveled at the precision and sophistication of the pyramid's known chambers and passages. The revelation that additional spaces exist, spaces that have remained hidden for over 4,000 years, forces us to reconsider everything we thought we understood about ancient Egyptian engineering capabilities. Consider the precision required not just to construct these hidden spaces, but to integrate them seamlessly into the pyramid's overall structure. The ancient builders had to account for the enormous pressures created by millions of tons of stone blocks, ensure the structural integrity of both the hidden chambers and the visible passages, and somehow accomplish all of this without leaving any external indication of what lay within. This level of architectural sophistication rivals anything achieved in the modern era, yet it was accomplished with tools and techniques we're still struggling to fully understand. The hidden chambers don't just represent empty spaces within the pyramid. They represent a level of planning and execution that challenges our fundamental assumptions about ancient technological capabilities. But the story doesn't end with detection. The real mystery begins when you start asking the fundamental question that has kept archaeologists awake at night: why? Why would the ancient builders create these elaborate hidden spaces? What purpose could they possibly serve that justified the enormous additional effort, the complex engineering challenges, and the resources required to construct them? To understand the magnitude of what we're dealing with, you need to grasp just how extraordinary the Great Pyramid's construction really was. We're talking about approximately 2.3 million stone blocks, some weighing as much as 15 tons, fitted together with a precision that would challenge modern construction techniques. The base of the pyramid is leveled to within just over 2 centimeters across its entire 230-meter span. The sides are aligned to the cardinal directions with an accuracy that wasn't matched by human engineering for thousands of years. Now imagine coordinating all of this while simultaneously creating hidden internal spaces that no one was supposed to know about. Every block placement, every architectural decision, every structural calculation had to account for not just the visible pyramid, but for these secret chambers as well. The ancient architects weren't just building what people could see, they were embedding a hidden layer of complexity that would remain undetected for over 4 millennia. The more we study these discoveries, the more questions emerge. Take the North Face corridor, for instance. Its position directly above the main entrance isn't random. In ancient Egyptian architectural thinking, every element served a purpose, whether practical, symbolic, or both. The corridor's chevron-shaped roof mirrors the design of the entrance below, suggesting a deliberate architectural relationship. But what kind of relationship? Some researchers believe these hidden spaces might have served a structural purpose, helping to distribute the enormous weight of the stone blocks above critical areas like the entrance and the grand gallery. Ancient Egyptian builders were masters of load distribution, and the pyramid's internal architecture shows sophisticated understanding of how to manage the incredible pressures created by millions of tons of stone. But there's another possibility that's even more intriguing. What if these spaces weren't just structural features? What if they were designed to serve some function we haven't considered? The ancient Egyptians didn't build anything without purpose. Every chamber, every passage, every architectural detail in their monuments served specific functions related to their complex religious beliefs about death, resurrection, and the pharaoh's journey to the afterlife. The Big Void, in particular, presents a fascinating puzzle. Its massive size, at least 30 meters long, with a cross-section similar to the Grand Gallery, suggests it wasn't just a minor architectural feature. Spaces this large require significant resources to create and maintain structural integrity around them. You don't accidentally end up with a void this substantial in a structure as precisely engineered as the Great Pyramid. Consider the context. The Grand Gallery itself is one of the most remarkable architectural achievements in the ancient world, a soaring corbelled passage that rises at a steep angle through the heart of the pyramid. Its function has been debated for generations. Some believe it served as a storage area for massive granite plugs that would seal the pyramid's passages after the pharaoh's burial. Others think it might have been a kind of counterweight system, helping to position the enormous stone blocks that sealed the burial chamber. Now we discover that directly above this already mysterious space lies another void of comparable size. The relationship between these two features can't be coincidental. They must have been designed to work together as part of some larger system we don't yet understand. This brings us to one of the most profound implications of the Scan Pyramid's discoveries. For generations, we've studied the Great Pyramid based on what we could access, what the ancient builders left open for us to find. We assumed we were seeing the complete picture, that the known chambers and passages represented the entirety of the pyramid's internal architecture. These new discoveries shatter that assumption completely. If there are hidden spaces we're only now detecting after 4,500 years, what else might be waiting to be found? The pyramid could contain an entire network of chambers, passages, and spaces that exist in a parallel architecture, invisible to the casual observer but integral to the monument's true function. The implications extend beyond archaeology into the realm of ancient technology and human capability. The precision required to create these hidden spaces while maintaining the pyramid's structural integrity suggests engineering knowledge that we're still working to fully comprehend. We're not talking about primitive construction techniques here. We're looking at sophisticated architectural planning that rivals modern engineering in its complexity and execution. But perhaps most intriguingly, these discoveries force us to reconsider the relationship between the living and the dead in ancient Egyptian society. The Great Pyramid wasn't just a tomb, it was a machine for resurrection, a carefully designed system meant to transform the deceased pharaoh into a god and ensure his eternal life among the stars. Every element of its construction served this ultimate purpose. If these hidden chambers are part of that system, they might represent aspects of the resurrection process that we've never understood. They could be spaces designed for rituals we know nothing about, or they might serve functions in the pharaoh's spiritual transformation that were so sacred, so essential, that they had to remain hidden from human eyes for all eternity. The ancient Egyptians believed that knowledge was power, and that certain knowledge was too dangerous to be shared openly. The hidden chambers might represent the physical manifestation of this belief, spaces that contain secrets meant only for the gods and the pharaoh himself. As the Scan Pyramids project continues its work, each new measurement, each refined image brings us closer to understanding not just what these spaces are, but what they mean. We're not just mapping empty rooms. We're decoding a message written in stone by some of history's most sophisticated architects, a message that has waited over 4,000 years for us to develop the technology to read it. The revelation of these hidden chambers has sparked something unprecedented in the archaeological world, a complete rethinking of what we thought we knew about the ancient past. But here's where the story takes an even more remarkable turn. The technology that revealed these secrets didn't emerge from archaeology departments or museum laboratories. It came from the cutting edge of particle physics, from scientists who spend their days studying the fundamental forces that govern our universe. The journey began decades ago with a Nobel Prize-winning physicist named Luis Alvarez. In 1965, 3 years before receiving his Nobel Prize, Alvarez had a radical idea. He was visiting the pyramids at Giza, standing in the shadow of these ancient monuments, when he realized that the cosmic rays constantly bombarding Earth might hold the key to seeing inside structures that had remained sealed for millennia. Alvarez understood something that archaeologists of his time couldn't fully grasp, that the universe itself could serve as the ultimate X-ray machine. The muons created by cosmic ray interactions in Earth's atmosphere don't care about human timelines or archaeological protocols. They've been penetrating the Great Pyramid every second of every day for over 4,000 years, carrying information about what lies within, waiting for someone clever enough to learn how to read their message. His initial experiment focused on the Pyramid of Khafre, the second largest pyramid at Giza. Using the technology available in the 1,960 seconds, Alvarez placed cosmic ray detectors inside the pyramid's known chambers and waited. For months, his equipment counted muons coming from different directions, mapping the density of stone above. The results were disappointing. He found no hidden chambers, no secret voids. But Alvarez had done everything right. His only mistake was choosing the wrong pyramid. Had he positioned his detectors in the Great Pyramid of Khufu instead, he might have detected the big void 50 years before the Scan Pyramids team made their groundbreaking announcement. Sometimes the most profound discoveries in science come down to being in the right place at the right time, with the right tools and the right mindset. But Alvarez's pioneering work laid the foundation for everything that followed. He proved that muon tomography could work in principle. He demonstrated that cosmic rays could penetrate massive stone structures and reveal their internal architecture. Most importantly, he showed that the universe provides all the tools we need to unlock its secrets. We just have to be clever enough to use them. Fast forward to the 21st century, and the technology has evolved exponentially. Modern muon detectors are thousands of times more sensitive than anything Alvarez had access to. Computer processing power allows researchers to create three-dimensional maps of incredible precision. International collaboration means that multiple teams can cross-verify each other's findings, eliminating the possibility of error or wishful thinking. The Scan Pyramids project represents the culmination of this technological evolution. But what makes their discoveries so compelling isn't just the sophistication of their equipment, it's the convergence of multiple independent measurements, all pointing to the same extraordinary conclusion. When the Japanese team deployed their nuclear emulsion films, technology originally developed to study subatomic particle interactions in high-energy physics experiments, they detected anomalies in the muon flux coming through the pyramid's north face. These weren't subtle variations that required statistical analysis to identify. The signal was strong, clear, unmistakable. The French team, using gaseous detectors based on entirely different physical principles, confirmed the same anomalies from different positions. Their measurements matched the Japanese findings with remarkable precision. The Egyptian team contributed essential archaeological context, ensuring that what the physicists were detecting made sense within the known structure of the pyramid. But perhaps most convincingly, when the teams moved their detectors to different locations and repeated their measurements, they consistently detected the same voids from multiple angles. This triangulation approach eliminated any possibility that they were seeing artifacts of their equipment or measurement errors. They were detecting real empty spaces within the pyramid, spaces that had remained hidden since the monument's construction. The process of confirming these discoveries required years of painstaking work. Each measurement had to be repeated multiple times to ensure statistical significance. Each detector had to be calibrated and cross-checked against known structures within the pyramid. Every possible source of error had to be identified and eliminated. Think about the challenge these researchers faced. They were trying to create detailed maps of spaces they couldn't see, couldn't access, couldn't physically verify. They had to rely entirely on the subtle variations in cosmic ray penetration, differences so small that they required months of continuous measurement to detect with confidence. The Big Void discovery, announced in 2017, represents one of the most rigorously verified archaeological findings in modern history. 3 independent teams, using 3 different technologies, detected the same massive space from 3 different positions within the pyramid. The statistical certainty of their measurements exceeds what's required for most scientific discoveries. But verification was only the beginning. Once they knew these spaces existed, the real questions began. The North Face corridor, with its precise 9-meter length and 2-meter by 2-meter cross-section, isn't a random void created by settling stone or construction flaws. Its dimensions are too regular, its position too strategic, its relationship to the entrance below too deliberate. The chevron-shaped roof of the corridor mirrors the architectural design of the entrance directly beneath it. In ancient Egyptian construction, such repetition of architectural elements wasn't coincidental. Every design choice served a purpose, whether structural, symbolic, or both. The corridor's roof wasn't shaped this way by accident. It was designed this way for reasons we're still working to understand. The Big Void presents an even more profound mystery. At 30 meters in length, it's comparable in size to the Grand Gallery, one of the pyramid's most impressive known features. But unlike the Grand Gallery, which serves as a passage connecting different levels of the pyramid, the Big Void appears to be a completely enclosed space. There's no obvious way to enter it, no connection to the known passage system. This isolation raises fascinating questions about its function. If it's not accessible from the rest of the pyramid, how did the ancient builders use it? Was it sealed permanently after serving some specific purpose during construction? Or was there originally an access route that was later blocked or disguised so effectively that we haven't found it yet? The positioning of the big void, directly above the Grand Gallery, suggests these two features were designed to work together. But work together to do what? The Grand Gallery itself remains one of archaeology's great puzzles. Its soaring corbelled ceiling, its precise angle matching the ascending passage below, its massive granite blocks, all point to some function beyond mere decoration or symbolic representation. Some researchers have theorized that the Grand Gallery served as a kind of counterweight system, helping to position enormous stone plugs that would seal the pyramid's internal passages after the pharaoh's burial. Others believe it might have been a resonating chamber, designed to amplify sound or vibration for ritual purposes. The discovery of the big void above adds another layer of complexity to these theories. Consider the engineering implications. Creating a void 30 meters long within a structure composed of millions of precisely fitted stone blocks requires extraordinary planning and execution. Every block placed above and around this space had to be positioned to maintain structural integrity while preserving the emptiness within. The ancient architects couldn't simply leave a gap and hope the weight above wouldn't cause collapse. They had to design a support system sophisticated enough to handle the enormous pressures involved. This level of engineering sophistication rivals anything achieved in modern construction. We're not talking about primitive building techniques here. We're looking at architectural planning that demonstrates advanced understanding of structural mechanics, load distribution, and material science. The fact that these spaces have remained intact for over 4,000 years, surviving earthquakes, temperature variations, and the simple pressure of time, testifies to the extraordinary skill of their creators. But the technical achievement, impressive as it is, pales beside the deeper mystery of purpose. The ancient Egyptians didn't build anything without reason. Every element of their monumental architecture served specific functions within their complex religious and philosophical systems. The Great Pyramid wasn't just a tomb, it was a carefully designed machine for transformation, a physical manifestation of beliefs about death, resurrection, and the pharaoh's journey to divine status. Within this context, the hidden chambers take on profound significance. They're not just empty spaces, they're integral components of a system we're only beginning to understand. Their concealment suggests they served functions so sacred, so essential to the pharaoh's transformation, that they had to remain hidden from human eyes for all eternity. The ancient Egyptian concept of Ma'at, the cosmic order that governed all existence, emphasized balance, harmony, and hidden knowledge. The pharaoh's role was to maintain this balance between the visible world and the invisible realm of the gods. Perhaps the hidden chambers represent this invisible realm made manifest in stone, spaces that exist in parallel to the visible architecture but serve entirely different purposes. As particle physicists continue to refine their measurements and archaeologists work to interpret the findings, we're witnessing something unprecedented: the convergence of cutting-edge science and ancient mystery. The same cosmic rays that help us understand the fundamental nature of the universe are revealing secrets embedded in humanity's oldest architectural achievements. The implications extend far beyond Egyptology. If structures this old can contain hidden complexities we're only now discovering, what does that say about our understanding of ancient civilizations in general? How many other monuments around the world might contain secrets waiting to be revealed by technologies we're only now developing? The Scan Pyramids discoveries represent more than just archaeological findings. They're forcing us to reconsider the relationship between ancient knowledge and modern science, between what we think we know and what remains to be discovered. In the hidden chambers of the Great Pyramid, we're not just finding empty spaces, we're finding evidence of human capabilities that challenge our fundamental assumptions about the past. And this is just the beginning. The technology that revealed these chambers is still evolving, still becoming more sophisticated. Each new measurement brings the possibility of detecting additional voids, additional secrets that have waited millennia for the right tools to reveal them. The Great Pyramid may contain an entire hidden architecture, a parallel world of chambers and passages that exist alongside the spaces we've always known about. The cosmic rays that revealed these secrets are still falling, still carrying information about what lies within. The ancient builders embedded their secrets in stone, but they couldn't hide them from the universe itself. Every day, every hour, these invisible messengers from space pass through the pyramid, ready to reveal their secrets to anyone patient enough, clever enough, and persistent enough to learn how to read their message. The question that haunts every researcher who has studied these discoveries is perhaps the most profound one of all. What happens next? The detection of these hidden chambers represents just the first step in a much larger journey. We know these spaces exist, we know their approximate dimensions, we can map their positions with incredible precision, but we still have no idea what lies within them. Think about that for a moment. After 4.5 millennia of human curiosity, after countless expeditions, theories, and investigations, we've discovered that the Great Pyramid still holds its most important secrets. These aren't minor architectural details or construction curiosities. We're talking about spaces large enough to walk through, chambers that could contain artifacts, inscriptions, or evidence that might fundamentally change our understanding of ancient Egyptian civilization. The North Face corridor, with its carefully engineered 9-meter length, might contain construction materials left by the original builders. It could hold tools, inscriptions documenting the building process, or ritual objects placed there for purposes we can't yet imagine. The chevron-shaped roof suggests deliberate architectural planning, not just empty space created by accident. But it's the big void that truly captures the imagination. A space 30 meters long, hidden above the Grand Gallery for over 4,000 years, represents one of archaeology's greatest unopened treasure chests. What could justify creating such a massive hidden chamber? What could be so important that it required this level of concealment and protection? The possibilities are staggering. The chamber could contain the pharaoh's actual burial goods, items too sacred or too dangerous to place in the accessible burial chamber below. Ancient Egyptian texts speak of objects of power, tools of transformation that were essential for the pharaoh's journey to the afterlife. Perhaps these items were never meant to be found by human hands, sealed away in spaces that would remain hidden until the pharaoh himself returned to claim them. Or consider another possibility. The ancient Egyptians were master astronomers, capable of calculations and observations that wouldn't be matched for thousands of years. The pyramid's alignment with celestial bodies is so precise that it serves as a kind of stone calendar, marking the passage of seasons, the movement of stars, the great cycles that govern their understanding of time itself. The hidden chambers might contain astronomical instruments, star charts, or calculation devices that would revolutionize our understanding of ancient scientific knowledge. There's also the tantalizing possibility of texts. The ancient Egyptians were prolific writers, documenting everything from daily administrative records to the most profound religious and philosophical concepts. Yet so much of their literature has been lost to time, destroyed by conquest, neglect, or the simple passage of centuries. A sealed chamber within the Great Pyramid could preserve papyrus scrolls, inscribed stones, or other written materials that have survived nowhere else. Imagine discovering the complete architectural plans for the pyramid itself, detailed instructions left by the master builders who created this monument. Such documents could finally answer questions that have puzzled researchers for generations. How did they achieve such incredible precision? What tools and techniques did they use? How did they coordinate the work of thousands of people across decades of construction? But accessing these chambers presents challenges that make their detection seem simple by comparison. The spaces exist deep within a structure composed of millions of precisely fitted stone blocks. There's no obvious way to reach them without causing potentially catastrophic damage to the monument itself. The pyramid isn't just an archaeological site, it's a UNESCO World Heritage Site, one of humanity's most precious cultural treasures. Any exploration must balance the potential for groundbreaking discoveries against the absolute necessity of preservation. Modern technology offers some intriguing possibilities. Robotic exploration systems, similar to those used in deep-sea exploration or space missions, could potentially navigate narrow passages or drill tiny access holes that would cause minimal damage, while still allowing cameras and sensors to enter the hidden spaces. Fiber optic technology could snake through microscopic openings, providing visual access to chambers that have remained in absolute darkness for millennia. The Japanese team has already begun developing specialized equipment for exactly this purpose. Their robots are designed to be small enough to fit through openings just a few centimeters wide, yet sophisticated enough to provide detailed imaging and analysis of whatever they encounter. These aren't simple remote-controlled devices. They're precision scientific instruments capable of measuring, sampling, and documenting with archaeological-level accuracy. As we stand at the edge of this extraordinary revelation, one thing becomes crystal clear. The Great Pyramid's greatest secrets may still lie ahead of us. For over 4 millennia, this ancient wonder has challenged every assumption we've made about human capability, about the limits of ancient knowledge, about what's possible when brilliant minds set themselves to impossible tasks. The hidden chambers, detected by cosmic rays from the depths of space, represent more than just empty rooms waiting to be explored. They're evidence that our ancestors embedded layers of meaning, purpose, and sophistication into their monuments that we're only now beginning to glimpse. Every muon that passes through those sealed spaces carries with it the potential to rewrite history itself. But perhaps the most remarkable aspect of this discovery isn't what we found, but what it teaches us about the relationship between past and future, between ancient wisdom and cutting-edge science. The same cosmic forces that help us understand the fundamental nature of the universe have revealed secrets hidden in humanity's oldest architectural achievement. The builders of the Great Pyramid couldn't have imagined that particles from dying stars would one day illuminate their most carefully guarded mysteries. What happens next will determine whether these hidden chambers remain tantalizing mysteries or become the keys that unlock entirely new chapters of human history. The technology exists to explore these spaces, to peer into rooms that have remained sealed since the pyramid's construction. But the real question isn't whether we can do it, but whether we're ready for what we might find. Because if the ancient Egyptians were capable of creating hidden chambers this sophisticated, this perfectly concealed, this structurally integrated into one of the most precisely engineered buildings ever constructed, then we may need to reconsider everything we think we know about the past. We may discover that the line between ancient and modern isn't as clear as we thought, that human ingenuity and capability have always been far greater than we dared imagine. The Great Pyramid stands today much as it did 4,000 years ago, weathered but unbroken, mysterious but magnificent. Its hidden chambers wait in perfect darkness, holding secrets that could change our understanding of civilization itself. And somewhere in the cosmos, particles are racing toward Earth at nearly the speed of light, carrying the next revelation, the next impossible discovery that will remind us once again that the past is never quite what it seems. The ancients built more than monuments. They built puzzles that span millennia, challenges that wait patiently for each generation to develop the tools, the wisdom, and the courage to solve them. The hidden chambers of the Great Pyramid aren't just archaeological discoveries. They're invitations, written in stone and sealed with time, waiting for us to prove we're ready to receive whatever truths they contain. If this journey into the heart of ancient mystery has left you questioning what else might be waiting to be discovered, Hit that subscribe button and join us as we continue exploring the hidden stories that shaped our world. Because the past isn't finished with us yet, and every cosmic ray that falls might be carrying the key to humanity's next great revelation.